Topic 3-1. This can be referenced with our Holt textbook in Chapter 1, Section 3 on page 22 through 23. First, we're going to start with definitions. An object consisting of one endpoint and continues infinitely in one direction. That's a ray. An angle is an object consisting of two rays called sides with a common endpoint called a vertex. Take a minute and copy these definitions. For the first example, name each of the following. Sides. Well, notice how this is where we start. So you have to start by a name. You would have to start with the vertex, which we actually answered this one. So your vertex is B. So your sides would have to start with a BA, showing it as a ray, and BC. Always naming the vertex first. If you're going to name the angle, you can either name it starting with the B, or you can name it angle ABC or angle CBA. Remember to put the vertex angle in the middle when you name an angle. Must be in the middle. Example 2. How does the diagram in example 1 differ from the diagram in this example? Well, in this one you have 3 angles. And we can't name this one angle P because angle P it includes 2 different angles. So you would have to name it. There's at least, 6 different ways these angles can be named. So let's name them all. Angle QPS, angle QPR, angle RPS, and notice that each one of these can go backwards. SPQ, PQ, and SPR. Notice again, P is in the middle of the name of each of these angles. Make sure you put your angle, showing it as an angle. So when we talk about it in a plane, an angle separates a plane into 3 distinct parts. We'll go over that too. You've got the interior, the exterior, the angle itself, and moving this up slightly. Let's look at example 3. Name a point in the interior of QPS in this example 2. So look at QPS. Again, this names the vertex. A point that's in the center of it would be point R. The interior, key word here. B says name a point in the exterior of QPR. So QPR, if this is the angle, the point on the outside or exterior would be point S. Okay, moving on to angle addition postulate. Move this down again. The angle addition postulate states in example 2, if R is the interior of angle QPS, then the measure of QPR plus the measure of RPS is equal to the measure of QPS. So adding these 2 angles together, then you would include R being on the interior of Q, P, and S. So just adding this angle plus this angle is going to give me the outside angle. So we're going to do a few examples. First, just using values and then using expressions. Example 4. If the measure of angle PQS is equal to 77 and the measure of PQR is equal to 32 degrees, then find the measure of RQS. Okay, so first let's just name it like it would for your angle addition postulate. You've got the measure. Noted that's how we would use when we say the measure of the angle. The measure of angle PQS is equal to the measure of angle PQR plus the measure of angle RQS. This was given to us as 77. This angle is given to you as 32. And RQS is this one right here. RQS. This is the angle they're looking for. That one was not given to you. So put that as a variable. To solve for the variable, we subtract 32 from each side. This goes away, so our x is equal to 45. So, to answer the question, the measure of angle RQS is equal to 45 degrees. Again, they were looking for the part on the inside of this whole thing. That's why you adding this one and this one together gives us the full angle. So let's try another one. Again, noting the addition postulate that the measure of the outside angle, AOC, is equal to the measure of the angle, AOB, plus the measure of angle, BOC. So let's read each expression. If the measure of AOC is equal to 70, and the measure of AOB is this expression, x plus 10, and the measure of BOC is x, they want us to find the solving for x, and then plugging it back in, we'll find the measure of each of the angles. So first, let's look at what they gave us. AOC is 70 degrees. The measure of AOB was x plus 10, and this one, BOC, was just x. Again, setting up the algebraic equation. Combining like terms gives us 2x plus 10 is equal to the 70. You've got to subtract 10 on both sides. That's going to give us 60 is equal to the 2x. So x, after dividing by 2, is equal to 30. Oh, can't see it. Alright, solving for x. X is 30. Put it on our blank up there. So BOC is x, so that's also 30. And if we add 10, we would find, because you're plugging it back in, you would find AOB, which is 40. Again, we're having to use some of our algebra skills for this. Alright, let's go over some classifications of the measures of different angles. Angles can be classified by the measure in degrees. If an angle has a degree measure less than 90, it's classified as an acute angle. If an angle has a degree measure equal to 90, it's a right angle. If an angle degree measures greater than 90 degrees, it's classified as an obtuse. If the angle has a degree measure equal to 180, it's classified as a straight angle. So again, your knowledge of the measures of degrees is important here. So let's look at example 6. For each of the following angles, A, they want you to name it, then tell whether it measures less than 90, greater than 90, or equal, or if it's equal to 180. And then we'll classify it by that, what it looks like. Okay, look at the first one. It's 35 degrees, and if we were to name this, you could name it angle YFS I, or name it by its vertex, angle F. This is less than 90 degrees, so it would be an acute. Okay, looking at this one can be named LTC angle, LTC, or angle T, naming it by its vertex angle, the one in the middle. It definitely measures greater than 90 degrees, so it is obtuse. Okay, naming this angle can be RTS, angle RTS, or angle T. Its measure, denoted by this box, is equal to 90 degrees. Therefore, it is a right angle. This one is still an angle, even though it looks as if it's a line, but you would denote it by angle NXS, or by its first vertex, angle X. Its measure is equal to 180 degrees. Make sure you remember that. All straight lines equal 180 degrees. Maybe put it big out there. Its classification is a straight angle. Okay, and that's the notes for that one. Last page in this topic. When angles have the same measure, they are said to be congruent. So an angle bisector. Definition: a line, ray, or segment that divides an angle into two congruent angles. So let's look at example 7. If ray, XY, is an angle bisector of angle WXY, name the two congruent angles that it forms. Well, notice that they're saying this is the bisector, this XY. They've named it by its starting vertex. You can actually mark congruencies with a curved line here and here to see. That means that value is equal to this value. So we can't name it by just an X. You have to name it with 3 letters. Angle WXZ is actually congruent to YXZ. So now we can move into some examples using some algebraic expressions to solve. So they want just the next example, they want us to find the value of X for the following, where FG bisects EFH. FG is the bisector of EFH. Mark it. Show that this angle and this angle are congruent to each other. And so they're giving us the measures of each one in an algebraic expression that we can set equal to each other. 5x minus 10 is actually equal to 3x plus 25. Solving this algebraically, we can subtract a 3x on each side, combining our x terms. This is going to leave us with a 2x minus 10 is equal to 25. Add 10 to both sides. Gets rid of our constant on that side. And then 2x would be equal to 35. So x would be equal to 17.5. Remembering our algebra skills. Okay, this one same way. If they're saying GFH, and EFH, oh, this is different, EFH, this would be the whole thing, so be careful. This represents the entire thing, so that's going to take up 2 of these. That makes sense. Because it's bisector, GFH is going to be equal to the same thing as EFG. So you have to have 2 of those. 2 of your 3x's plus 20 is equal to the 4x plus 80. So remember, first we have to distribute. You're going to have to say the 2 times the 3x, and then the 2 times the 20. 6x plus 40 is equal to the 4x plus 80. We're going to subtract 4x on both sides, giving us a 2x plus the 40. Those go away. We're going to subtract 40 on both sides. This becomes 2x is equal to 40. Therefore, x after dividing by 2 would be equal to 20. And that concludes section or topic 3-1.